Good day. So far, we've dealt with the aliphatics, and that means you should now know how to name and write formulas for alkanes, alkenes, and alkynes. You should also know how to deal with cyclic compounds, cycloalkanes, and you should also have dealt with the aromatics. And again, it's being able to go from a name to a structure and a structure to a name. Well, the same is true for the functional groups, and so we're going to hit you today with this. And it's basically to get your feet wet with it, and the next period then we'll come at it again, and if it doesn't come easily to you, you got to work at it. So a functional group is simply an arrangement of elements, the atoms of certain elements, that give a compound certain properties. And so we're going to look at a sampling here, and for the most part we're going to worry about how to draw structures and how to name them. In this video, it will really be, the information's pretty well already there, and then I'll have a PowerPoint that will give you more practice on it, and another PowerPoint gives you practice, and probably some other sheets that'll do the same before we turn you loose on some assignments. So alcohol is based on OH, and if that was attached to a metal, we know it would be a base. But in this case, the OH is going to be attached to a carbon. And when it's attached to a carbon atom, it ends up being an alcohol. So here we talk about how do we name these things. Well, if this is an alkane, we get rid of the E and the ending changes to OL, just like alcohol ends in OL. So this would have been propane, and now it is propanol. The OH can appear on any carbon in the chain, and therefore, as soon as we have more than two carbons in our longest chain, we have to put an address. If it was one carbon, it would just be methanol. Two carbons would be ethanol. As soon as we're at propanol, we have to say, is it one propanol or two propanol? So we know the OH in this case is hanging off an end carbon. Same thing for butanol and beyond. We have to know if it's one butanol or two butanol. Now ethers are close to alcohols, but instead of H here, we have another carbon chain. So here we would have had a carbon chain. And so oxygen's in the middle, carbon chain on one side, carbon chain the other. And ethers always occur in the middle of a chain. So the naming of this is you treat one chain as the main chain. And that becomes the alkane name. And then the branch, which will be the shorter branch of carbons that's attached to the oxygen, is treated as a branch. And its ending changes to oxy, so we're including the oxygen in it. So when we look at this, we have propane, and then it goes 1-ethoxy. So this would have been an ethyl branch. Ethyl oxygen becomes ethoxy. And then the 1 is saying it's attached to an end carbon right here. So you can see there's a lot going on already. Next we have things called aldehydes, and you might have heard of formaldehyde, which is used to preserve specimens so they don't rot. But formaldehyde itself is a very nasty chemical. Well, aldehydes contain the carbonyl group, and a carbonyl group is C double bonded O to an O, and then goes to a carbon chain in one direction. And in the case of an aldehyde, it'll go to a hydrogen in the other. And in fact, this would be trigonal planar because it's AX3. So if we're trying to show it structurally, this R would represent some sort of carbon chain, C double bonded to an O, and then an H. But a lot of times it's inconvenient to show that if we're typing questions out in a book or something. So you have to recognize that when it says CHO, it actually represents C double bonded to an O and then to an H. Aldehydes, the carbonyl group is always at the end of the chain, and so we don't have to indicate the location of the carbonyl group. We know it's automatically carbon number 1. And since it's aldehyde, starts in al, the suffix becomes al. So here we have ethanal. And there's two carbons in chain, so the carbon with the carbonyl is included in the chain. There's our ethane, and the ending becomes al, so it's ethanal. and we don't have to put any kind of number in at this point. If we get to more exotic aldehydes, which we will, these things will have branches and then we'll have to worry about locations, but plenty of time for that. This is just getting you used to the game. There's another chemical based on this carbonyl group, and that is the ketone. And the ketone is like an aldehyde, except the carbonyl group cannot be at the end of the carbon chain. It has to be somewhere in the middle. So this says ketone, and our suffix is going to be -one. It is not one, it's -one, like bone or phone or cone. So when we're going to name this thing, here's our example. We have 1, 2, 3, 4. We have 4 carbons in a row, so it would have been butane. But now we get rid of the E, put in the ONE for ketone, -one, and we get butanone. You will notice I didn't put a number for it because it can't be on this end carbon, and the carbonyl can't be on this end carbon. It would have been aldehyde. It has to be on one of the interior carbons. And therefore, this is second carbon in. If it's on this one, I just count from the other side, second carbon in. So this is the only possible thing we can get for butanone. Once you're at pentanone with 5 carbons in a row or bigger, then you have to put a location for where the carbonyl group is. So we're going to stop here, and we'll pick up with this set of notes and formulas in the next video.